In examples 12 through 17, we are going to revisit the 5 situations in example 5 that we said should be worked with the future value of an annuity formula. So starting on page 9 of the 3.2, 3.3 notes, I have the same 5 situations listed here, and I think I even added in an additional one. So at the top of the page, here is the formula for the future value of an annuity. This is here just to remind you that we're working the following problems using this formula. Okay. As we go through each of these, I will remind you, what we talked about in example 5 as far as why each one it needs to be worked using the future value of an annuity formula. And then we'll go ahead, decide what variable we're looking for, state the values of all the other variables, and then plug into the formula and solve. Okay, so let's start with example 12. Okay, example 12 corresponds to example 5I. Okay, so if you need to go back and look at that. What is the final balance of a retirement account earning 5% interest compounded weekly if $40 is deposited at the end of every week for 35 years? And then how much of this final balance is interest? Okay, so back in example 5, we talked about why this problem needs to be worked using the future value of an annuity formula. Okay, first of all, you see the phrase compounded weekly, so that eliminates simple interest, okay? Let me get this thing to focus, hold on. You are saving money, so that narrows it down to compound interest or to the future value of an annuity formula. So you need to look at how often you're making the deposits. You're depositing $40 at the end of every week, okay? So those are regular deposits, and you're saving money. So you're going to use the future value of an annuity formula. Okay, so that's up here. So definitely more complicated than the compound interest formula. Okay, so let me go ahead and write it down. All right, and then we'll solve the problem. Okay, so here's my formula. Okay, so what we are looking for, if you read this carefully, we are looking for the final balance of the retirement account. Okay, so we're looking for A, and then we should know everything else. Okay, so remember with this formula, P is going to be the amount of each deposit. We're putting in $40 every time, so P is going to be 40. The interest rate is 5%, so 0.05. We are compounding weekly, so M is 52. And then time, the money is staying in there for 35 years. Okay, so again, you are taking $40, putting it into your retirement account every week, and the interest is being compounded every week, and the money is staying there for 35 years, no withdrawals, and you're earning money through the continued deposits and through the interest. And so you want to come back after 35 years of saving and see how much money you have for retirement. Okay. All right. So let's plug everything in and solve for our account balance. Okay. So let me go ahead and plug everything in. It's going to look like this. Okay. So that's it. Okay. All right, so we're going to plug this into the calculator. Okay, like I said, it is definitely more complicated than compound interest. Okay, when you work with this formula, okay, you want to start with the most complicated part. Okay, so we're going to start inside the brackets as far as entering this into the calculator. And if you look between the numerator and the numerator seems more complicated. So we're going to start there. We're going to punch in the numerator. And then once we have that, we're going to divide by the denominator. And then that will give us the quantity inside the brackets. And then once we have that, we will multiply by 40, and that will give us our A value. Okay, so let's do this on the calculator. All right, so I'm kind of working my way, I'm working inside out. Okay. All right, so like I said, we're going to start in the numerator. So you're going to type it in like you see it. So in parentheses, 1 plus 0.05 divided by 52, close parentheses, raise it to the power. You cannot do that in your head more than likely, okay? So you're going to need to put the exponent in parentheses, 52 times 35, close parentheses, and then you can go ahead and subtract the 1. This is the numerator. Okay, so hit enter. It's going to give you that decimal. Then we're going to divide by the denominator, the r over m. Okay, so we're going to hit the division key. It's going to divide that numerator. It's going to take the numerator and allow us to divide by r over m. You need to put it in parentheses if you have an older calculator, so that it's done in the correct order of operations. All right, so we're going to divide by, in parentheses, 0.05 divided by 52, close parentheses, hit enter. That is going to give us the quantity in brackets. Okay, so now what we need to do is multiply that by 40. So hit times. It's going to take that previous answer. You're going to multiply by 40, and that is going to give us our account balance. Okay, so this is going to be $197,590. I'll go ahead and write out the whole decimal expansion, and then we'll go ahead and round it. Okay, so that's what you get. All right, and so if we round this to the nearest cent, okay, here are your cents. You look at the number after, it's a 3, so it's going to stay the same. Okay, so your account balance after 35 years is $197,590.27. Okay, I'll even write that here, account balance. And then the second part of the question asks for how much of this is interest, okay? How much of the final balance is interest, okay? This is an annuity. There are regular deposits, okay? This is not a simple interest problem, so you cannot do I equals PRT here, okay? This is going to come down to using your common sense, okay? This is my total amount. This is the account balance after 35 years. Think about how much you contributed, okay? You contributed $40 at the end of every week for 35 years, okay? So to calculate the interest, okay, the interest is going to be the account balance minus the contributions. Okay, so how much was contributed? Okay, well, $40 a week. Okay, so there's 52 weeks per year. Okay, so this is how much was contributed in 1 year. Okay, and then we're going to multiply by 35 because this was done for 35 years. So we're going to go out to the side or go to the calculator and figure out what 40 times 52 times 35 is. Okay, that's $72,800. Okay, that's how much you put in. The rest is interest. Okay, so we are going to do $197,590.27 minus the $72,800, and that is going to give us the interest. Okay, so the interest is going to be, let's see if we subtract that out. I'll just do it on the side over here. Let's see what we get. Okay, look how much of this quantity is interest. Okay, you always hear to start saving for retirement as early as you can. This is why. Okay, look at the account balance and then look at how much is interest. Okay, so that's the interest portion. Okay, so again, kind of check yourself. Does this make sense? Okay, that's a reasonable amount for a retirement account. Okay, and think about what you did. You made, this is how much you put in. Okay, so if you subtract it out, the rest has to be interest. Okay, all right, so that's the end of this problem. So we will start working on example 13 now.